Welcome to the Mechanical Minute. These are quick videos on random relevant topics that pop up for you to keep and reference when needed. Why can't the code just tell me, right? That's the question. We want every code to just tell us what's wrong with it. When you see circuit high, low, open, or short to voltage or ground, they can tell you some stuff, but not everything. What's the difference between these? The circuit high is voltage above working parameters. Circuit low is voltage below working parameters. Circuit open is an incomplete path. Short to voltage is an unintended path to source voltage, and short to ground is unintended path to ground. So if the definitions are different specific, why can't the computer just tell us which one it is? Technically it can, but only to a point. The ECM can distinguish between high or low and power and ground. When it comes to reference circuits, it can't tell you past that. And to fully understand why, we need to understand the circuit and how it works. We know in these reference circuits, the voltage value changes based on the resistance value of the sensor. So the hotter it gets, the less resistance to ground it has. Voltage goes higher on the reference side for PCM to read. In 5-volt reference circuits, the variable resistor circuits like a coolant temp sensor, the working range is not actually 0 to 5 volts. They're more like 0.5 or 0.8 volts on the low side and up to 4.5 or 4.8 volts on the high side. Same set holds true with 12-volt circuits, as working range is not a true 0 to 12 volts. The working range is because engineers realize that ECM needs to be able to rationalize the working range for the sensor to be able to determine if there is an issue. If the working range voltage was at full 0 when it's cold, how would we know when it didn't work or had a problem? If the voltage was 0, how would the PCM know to put the light on or alert the driver? It wouldn't be able to, and would just have to assume it is working fine. It was just always cold, right? Think of it this way. If 0 volts was cold and the voltage in the circuit was removed due to a cut wire or whatever, the PCM wouldn't be able to distinguish the difference. So by giving it a working range parameter, we were able to tell if there is an issue when it falls outside this window. Now when the voltage goes above or below the working range to full 5 volts or less than 0.5 volts, or whatever the parameter is set at, the computer can determine the circuit is high or low because it is higher or lower than working range. This will usually result in the code. The diagnostic definition issues lie in the fact that it does not know if it's higher than 5 volts because that's all that it can see. So it could be shorted all the way to 12 volts, and all it can determine is that it is high because it can't see past the 5 volts outside the 5-volt monitoring window. Hence the code circuit high, or circuit short to voltage or open, because in this picture you can see this is what it actually sees, and it just sees it climb outside that 5-volt window, which looks like an open circuit, right? It has voltage that can be seen going above the working range, so it can tell it's on the high side. The ECM puts both codes in because it can't distinguish the difference. Some will show one or the other, but essentially they all mean the same thing. It's just outside that working range. The same concept is true in the other direction as far as lower short to ground or open, although it can technically still see a value of up to 0.49 volts or even 0.79 volts, whatever that parameter is when they code it. Nothing is in the working range window, as you can see. So obviously, because it can't see nothing in the window to determine no working range voltage, it has to be low, right? Or as far as the PCM is concerned, grounded or even open. So, like stated in the beginning, the ECM can tell you some things to a point. Things like voltage or ground side can be determined due to the working range, but open or shorted cannot because it cannot see that far outside the 5-volt window. And there you have it. If you know how something is supposed to work, you can better determine why it isn't working. This has been a Mechanical Minute.